All right, so now we are on to the next lesson, R3. And I said earlier that we are going to do a little bit of geometry. Geometry.
They can hear me right now?
They can.
That's tough. Hey, guys.
All right, here we go. Let's draw something. And I would hope you know what this is. Yes, it will be a triangle in a second. There we go. What kind of triangle, though? Looks like a right triangle, doesn't it? But can I assume, if you see a picture like this, can I just assume that that's a right triangle? I cannot. What do I need to be able to say for sure it's a right triangle? I need that little box right there that shows it's 90 degrees. Everybody's watching now, right? You guys were great when I was going over the quiz. Now I need you to pay attention. All right? So this indicates that it's a right angle. So a triangle, or a right triangle, has one right angle. Could you have a triangle that has two right angles? You could not, because if this was a right angle, it would just go straight up. Is there any way that you could make a triangle out of that? There's not, okay? So a right triangle can only have one right angle. You with me on that? Okay, let's write what this is down. So it's a right. Do you know the symbol for triangle? It looks like a triangle. So if I do that, that means it's a triangle. This thing right there, what's that little symbol right there? That's an angle. Okay, everybody got that? All right. Now, let's describe some of the stuff on this right triangle. This side right here is the side opposite the right angle. So if I'm at the right angle, if I go across from it, not next to it, but across from it, I give that a fancy math. Well, I give this side a fancy math name. These two sides would be adjacent, but this would be what? On a right triangle. This only happens on a right triangle. It's a big fancy math word. Hypotenuse, right? Yeah, is it ringing a bell? It's been a couple years, right? But that's the hypotenuse, okay? And this one's not as fancy, but these two sides right here, we call them the sides of the right triangle, or more specifically, we call them the legs of the right triangle. Okay, so that's a leg and that's a leg. You got it? Okay. So now, we do some stuff with right triangles. We do a lot of stuff. In fact, there's whole entire courses, not just a chapter, but there's whole entire courses on right triangles. Anybody know the name of that course, that math course? It's called trigonometry. You ever hear that before? Trigonometry is a whole entire book, a whole entire course just on right triangles, basically. Okay? There's a little more than that, but basically it's about right triangles. All right, so let's do another right triangle. Let's see if I can grab this and grab that. There we go, copy and paste. Look at that. We'll group it together. There we go. Now, what we're eventually going to do, now we don't have enough time today, but eventually what we're going to do, well, maybe we do have to do this one thing. A lot of times, we're going to do this. Is this starting to ring a bell when I put A, B, and C there? Yeah? There's a relationship. I'm not going to go through why it is and all that. I'm just going to show it to you, all right? There's a relationship that says this, that A squared, do you remember this? Plus B squared equals C squared. We have a name for that. It's named after some old guy a long time ago. Do you remember? Very good. It's called the Pythagorean theorem, okay? Pythagorean theorem. I'll just, let's write out the whole word. It's named after a guy a long time ago, and his name was Pythagoras. Pythagoras. Okay? Pythagoras. So they give him the name, right? If you're from Delaware, you're a Delawarean, right? So Pythagoras, they named it after him, so it's the Pythagorean theorem. We only got like 5 minutes. Can you wait? Okay. So what in the world does this mean right here? Let's everybody look. I know everybody's all excited. Got you all keyed up with the Pythagorean theorem. So let's figure out what in the world this means. So I'm glad you asked. So let's do an example. If I could grab this. Come on. There it goes. Let's do an example on this thing right here. I'm going to do a real easy one. 3 and 4. And what we're going to have to do is we're going to have to solve for C. Okay? This only works for right triangles. Everybody hear this? Pythagorean theorem only works with right triangles. So you cannot have an acute or an obtuse triangle. This only works with right triangles. Yes? Yeah, good point. I meant to mention that. C right here is always the hypotenuse. All right? We always call it the hypotenuse. It's the longest side of the triangle. The hypotenuse will always be the longest side of the right triangle. Everybody got that? Okay, so that's good. Thanks for pointing that out. So let's do some math on this. So the A and B, it doesn't matter which one you pick. It doesn't make any difference. So whether this is the A is the 3 or the 4, it doesn't make any difference. But let's just say it's the 3. So what do I do with this 3? I square it because of this little formula right here. Now there's a lot to this formula. I could have gone through a whole bunch of background to it, but I'm not going to. I'm just going to show it to you. If I was in geometry class, I'd probably do a lot more with this. But the B, what is the B in this situation? It's the other one, which is 4. And of course, we're trying to find what? The C. So I put C squared. So how do we do this? Let's do the math. What's 3 squared? 3 times 3. That's 9. Plus 4 squared is 16. And that equals C squared. What's 9 plus 16? It's 25. That equals C squared. I think we may, I don't know if we talked about this or not, but there's a rule in algebra. You just finished Algebra 2. You should remember this. There's a rule in algebra. If we want to get rid of something that's being squared, we do the opposite. So what is the opposite of squaring something? Square root. I think we might have talked about that in here, didn't we? Yeah, I think we did. So here's what you can do. You can take the square root of this side. Remember, yeah, I did. I remember talking about this. The square root and the squares cancel each other out. Remember that? But if I do something on one side, talk to me. I got to do it to the other side, okay? So I got to do that. So what is the square root of 25? What number times itself is 25? 5. So that means C is equal to 5. This is a special kind of a triangle. There's several different special kind of triangles. This is one of them, and this one shows up a lot. This actually, I'll give you a hint on the SAT. If you take the SAT, at least I remember years ago teaching an SAT course where there are situations where you have 3, 4, 5. Instead of going through all this mess right here to get to 5, if I would have seen this 3 and this 4 as the legs, I wouldn't even have to think about it. I would automatically just say that C was 5. That would save you a lot of time on the SAT, okay? And there's other ones. What if this was 6 and this was 8? Just in the top of your head, quick, what's C? It's 10. Because what did I do? I doubled 3, I doubled 4, so I would double what? 5. You with me on that? That's a really nice hint on the SATs because they like to do that a lot. And they also do that with some of the other special triangles, okay? I don't think I've done enough to officially assign the homework. So we'll put that off until tomorrow, okay? So I'll do some more tomorrow, and then I won't give you homework tonight. All right, we good? Okay.